Pre-statistics. Make predictions with quadratic models, part 3. In the two previous videos, all the examples had x-intercepts that could easily be identified by simply graphing in the standard window. Let's do an example that involves a little bit more investigative work. Example 4. Find the x-intercepts of the graph g of x equals negative 5x squared plus 90x minus 45. We'll begin by graphing g of x. So we go to the y equals. We type our function in, 5x squared plus 90x minus 45. We go to zoom, then 6, and this is what the graph looks like. It almost looks linear. We do see one x-intercept here. It's either at 1 or something close to 1, but we don't see our second x-intercept. So what do? Well, one approach, we could use the table. Another approach, we could, since the quadratic is symmetric about the axis of symmetry, we could compute the axis of symmetry, and that will help us set this viewing window. And this is important because the viewing window will help us identify the important pieces of the parabola. We can use the axis of symmetry to help us get the correct viewing window, so we can use our zero command if we'd like, or if we'd like to trace, or even get an idea of what to put the table set at. To compute the axis of symmetry, if you recall, the formula for the axis of symmetry is x equals negative b divided by 2a. In this example, this will become negative 90 divided by 2 times negative 5, which gives us a positive 9. So the axis of symmetry is at the vertical line x equals 9. To find the y-coordinate of the vertex, we substitute this value of 9 back in, so we have g of 9 equals negative 5 times 9 squared plus 90 times 9 minus 45. This gives us negative 405 plus 810 minus 45, which gives us a value of 360. So the vertex is at 9, 360. So knowing that the vertex is at 9 and we saw an x-intercept close to 1, that's about 8 units to the left of the axis of symmetry. So we want to go about 8 units to the right because the parabola is symmetric about this axis of symmetry. So this is going to help us set the x-min and the x-max. This value here, 360, this is a maximum value. We know this because a is negative, and if a is negative, the vertex is a maximum. So this will help us determine what our y-max is. To determine what the y-min should be, let's compute the y-intercept. And if we compute the y-intercept, we let x be 0 and solve for y. And of course, this becomes the value of c. So when x is 0, we have a negative 45 for the y. So let's take this information and adjust our viewing window. So we go to Window. For my x-min, we have a x-intercept at 1, and I'd like to see the y-axis, so I'm going to use negative 5, something a little to the left of the y-axis. For my x-max, I know that the graph on the right hand side needs to be about 8 units larger than the axis of symmetry. So the axis of symmetry was at x equals 9. If I add 8 onto 9, I get about 17. So I'm going to let the x-max be about 20. Okay, this span is about 25, so I'm going to count by 2's. For the y-min, our y-intercept was a negative 45, so I'm going to use something a little bit smaller than that. And I'd also like to see, when we use the 0 command, the values displayed at the bottom of the screen. So I'm going to set the Y min as a negative 100, and we'll look at it and see how it looks. The Y max, the vertex happened at 360. I'm going to make my window a little bit larger than that. Let's say 500. And this span is 600, so I'm going to count by 50s for the Y. Now we hit graph. This is a lot better picture. Here we can see one x-intercept. Here we can see the second x-intercept. I can see the y-intercept, and we can see the location of the vertex. I could use the trace feature or even the table, but I'm going to use the 0 command to identify the x-intercepts. So you go second and trace. Number 2, we got to give it a lower bound, so I need to go to the left, and I think any negative number will do. Okay, so now x is negative. Hit enter. Here's my little arrow. I want something more than 1. Okay, here's 1.1. Hit enter. And then for the guess, I'm going to scoot it a little bit closer to the x-axis. Hit enter. Here, the calculator is identifying 0.51 to 2 decimal places. Okay, let's compute this x-intercept. So I go back to the 0 command, move the cursor to the left of the second x-intercept. I think that's good. Now we want a right bound, so I'm going to move it more to the right, then hit enter. And now the calculator is looking in this domain, and I'm going to scoot the guess up a little bit closer. Say here, hit enter, and the calculator is saying the x-intercept is about 17.49. Now this negative 1e to the negative 10, this is scientific notation. And what this means is this number here is very close to 0. We would have about 9 zeros and then a 1. So this is very close to 0. Let's look at this using our table. If I go to table set, let's see what the table looks like. Starting at 0 and counting by 1s. When x is 0, we have a negative 45. When x is 1, we have a positive 40. Here we can see a sign change. So that means there's an x-intercept in between 0 and 1. Now, if I go to the left, we see these numbers are getting more negative. As we go to the right, the numbers are increasing. Getting larger. And then here, x equals 9. That was our largest value, our maximum, 360. And then when we move, the numbers are decreasing. And now we see we have a sign change. So we went from 40 to negative 45 across the x-axis again. If we need a more precise number, we can always go to table set. Let's start it at 17 and let's count by 0.1. And again, we're looking for that sign change. So these are positive numbers, and then as soon as I get to 17.5, there's a sign change. If we need to be more precise, we can start at 17.4 and count by 0.01 or even 0.005, whatever you'd like. so you can take it to whatever number of decimal places that you need. Limitation. The 0 command has a limitation. There must be a sign change in the y values for the calculator to determine a 0. And again, a 0 is the same thing as an x-intercept. If the graph touches the x-axis but does not cross it, then the calculator will return an error message saying that there is not a sign change. So let's look at an example of this. Let's go to our y equals. Let's do x squared. Let's do zoom number 6. And here we can see, looks like there's one x-intercept. And if we go to our table, let's go to table set and change it 0, and let's count by 1. Okay, we can see when x is 0, y is 0, and this is going to be the only x-intercept. Because if we take a positive number and square it, we get positive. If we take a negative number and square it, we get positive, because negative times negative is positive. So in this case, there's only one x-intercept at 0. But if we go back to the graph and we use our 0 command, so we'll go to the left of 0, hit enter. We go to the right of 0. Then this is telling me it's going to look for sign changes in between these two little arrows, and we'll put the guess something close to 0. Enter. And this is the error message I was talking about. No sign change. So the way the calculator uses the 0 command is looking for a sign change from positive to negative or negative to positive. And if there's not a sign change, this command will not report an x-intercept, even if one exists. So this is a limitation of using the 0 command. And it's always a good idea to look at it graphically, but also numerically. And eventually we will solve these equations algebraically also. Let's do a summary. To find the x-intercepts of a quadratic function graphically on the graphing calculator, number 1, you put the equation in y1, press graph. Number 2, identify any x-intercepts in the graph. Now note, just like the previous example, you may have to change the window settings. Sometimes calculating the vertex can help. Number 3, the 0 command, second and trace, and then the number 2 can help once you have a visual of the intercept. To find the x-intercepts of a quadratic function numerically on the graphing calculator, put the equation again in y1 and use the table command, which is second graph. Look for values of 0 or for sign changes, positive to negative or negative to positive. Then use the table set command, which is second window, to change what the table counts by in order to help you get closer to the value of the intercept. Thanks for watching.